Hello, I'm Pharma Omics. Today I want to talk about permutation-based FDR Perseus built-in programming features. Okay, what is FDR? Usually, the p-value in thousands of proteins are computed simultaneously, which causes multiple testing problem. The multiple testing problem arises when researchers conduct multiple statistical tests simultaneously, leading to an increased probability of obtaining false positive result. So correcting this bias is needed for the later process. Statistical method which can correct this bias is Bonferroni correction and false discovery rate method. FDR, which today we will see include Benjamini-Hochberg FDR and permutation-based FDR. Let's see the permutation-based FDR. It is a variation of the traditional FDR method that incorporates permutation testing. This method can be used and recommended in Perseus program. If the calculated Q value of a protein is less than specified FDR, it is significant. This is how to calculate Q value in permutation-based FDR. If you follow me, you will understand the principle of permutation-based FDR by the end. Okay, let's see the first step. Compute the p-value statistics analysis or t-test for comparing two groups or ANOVA for comparing more than 3 groups for each feature in our measured data. There are 2 groups, Group A and Group B. So we will do t-test for statistical analysis. And there are 4 samples in each group. Group A have case from 1 to 4 and Group B has control from 1 to 4. Each sample have 5 proteins from A and to E. P-values can be calculated for each protein. I assign the p-value arbitrarily. The next step is permitting the labels of the sample among groups. In our measured data, there are only case samples in Group A and there are only control samples in Group B. However, after permitting the labels of samples, each group has 2 case samples and 2 control samples. P-value can be calculated for each protein. This p-value in permitted data is different from p-value in measured data as the samples in each group have been changed. And permit the measured data again. In this data, Group A has 1 case sample and 3 control samples, and Group B has 1 control sample and 3 case samples. And p-values in each protein is calculated. And permitting and calculating p-value one more time. Now we have 4 data sets, 1 measured data and 3 permitted data. And each data sets have 5 p-values and there are 20 p-values in all data sets. Values from permitted data are colored green and those from measured data are colored brown. Then the p-values are sorted in ascending orders. Okay, now we will be ready for calculating Q-value. Let's calculate Q-value. Q-value is calculated dividing the number of p-values from permitted data less than p-value of protein which I want to get by the number of p-values from measured data less than p-value of protein which I want to get, and divide by the number of permutations. the example help you understand. Let's see the example. Let's calculate the Q value of protein E. The P value of protein E is 0.5. First, see the numerator of previous equations. Numerator is the number of P values from permitted data or less than P value of protein which I want to get. In this data, P values from permitted data are colored green. How many P values from permitted data are less than 0.5? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. And what is denominator? The denominator is the number of P values from measured data less than P value of protein which I want to get. In this data, P values from measured data are colored brown. How many P values from measured data are less than 0.5? 1, 2, 3, 4. 4. Next, note it should be divided by the number of permutations, 3. So why is it divided by 3? Q value is fraction of the permitted data over measured data, right? However, the permitted data have 3 times P values than measured data. So, dividing by the number of permutation is needed for normalization. Okay, so the Q value of protein E is 9. Divided by 4 divided by 3. It is 0.75. So it is bigger than 0.05. So the protein is not significant. Let's summarize what we have learned. In Perseus program, there is permutation-based FDR for correcting multiple testing problem. There are 5 steps for calculating Q values of permutation-based FDR. If the protein of Q value calculated is less than specified FDR, it is significant. Thank you for watching. See you next video.